Hello everyone, this is my final presentation. It's a survival analysis of the influence of ketosis in early lactation on pregnancy in dairy cattle. Because the video will block some of the graph in the following slides, so I turn off the video. Last time, we talked about the dataset of this study, and we have around 5,000 cows from 38 dairy farms, and how we deal with all the parameters. So the first question I have is whether I should include all the lactation from all the cows. So here we can see most of the cows are in first, second, and third lactation period, and we have a mean of 2.7 lactation. 95% of the cows are within lactation period 4.3. And if we do the lactation with the mean milk BHB, we can see that in each parity, there is not really a big difference of their mean milk BHB level. But cows in higher parity, there are just a few samples, so maybe there's a big bias among those samples. Also, if we do the farm level of the lactation, we can see in most of the farm, the lactation distribution are approximately with the same trend. They have most of the cow in their first and second parity. So I decide to abandon cows with higher parity, and I only include cows, 95% of the cows. So lactation over 5, the cows are removed before analysis. And because farm size is also very important, will affect the milk BHB level and the fertility performance. So I decide to define my farm size. And the farm size is based on the number of cows included in this study in each farm, and based on the 25%, 50%, and 35% quantile, I divided the farm into small, middle, and large farms. So now we know that farms are divided into 3 different farm size, and also I divide my lactation into 3 categories. And keto cow 1 is whether the cow has the mean milk BHB level over 0.08. If so, it's 1. If not, it's 0. And the cow will be seen as non-ketotic. And the end time is the days between last observation and the calving dates of the cows. And the pregnant is the pregnant status amongst our observation time. So if the cows are pregnant, it's coded as 1, and if not pregnant, or we are not sure about the cow's pregnancy status, it's coded as 0. So here we can see that pregnant status 0 means the cow is not pregnant after calving, or it has an unclear pregnant status. And pregnant status 1 is the cows that are pregnant. So the pink is the first lactation, green is second, blue is 3 or above, we can see that the average milk BHB among these three lactation groups in the non-pregnant cows group is slightly higher compared to the pregnant cows. And in this graph, we can see that the keto cows 0 means the cows whose mean BHB is less than 0.08 micromolar per liter. And keto cow 1 means the blue is the cows whose mean milk BHB over 0.08. So here we can see that in lactation first and second, the ketotic cows have slightly less open days than the non-ketotic cows. And in the lactation 3, the result is slightly different. So the ketotic cows have a slightly higher open days than non-ketotic cows. And in this graph, we can see that pink is the non-pregnant cows, and the blue is the pregnant cows. So among these three different farm sizes, we can see that the pregnant cows, which are blue, have a slightly lower average milk BHB level compared to the non-pregnant cows. So because this is a cohort study and I want to see whether the cows is pregnant at the end of the observation time, so I decided to use survival analysis to observe cows from the time, which is day of calving, to the events, which is pregnant. In this dataset, we have around 200 censored cows and 3,400 pregnant cows and 763 missing cows. So first, I do the Kaplan-Meier plots to see whether the survival function among ketotic and non-ketotic cows are different. And in the left-hand side, we can see that around the open day 300, there is a cross. So within the 300 days, the cows with lower mean BHB value have a stiffer line, which means the cows are more easily to get pregnant. However, after 300 days, the slope change. So after open day 300 days, the cows with lower mean BHB value are more smooth. The curve is more smooth than the curve of higher BHB cows. And on the right hand side, there's a cumulative hazard function. So we can see that before open day 300 days, the cows has lower milk BHB mean will have a higher hazard, which means more easily to get pregnant. So I decided to use the close proportional hazard regression to see whether the open days are influenced by exponential variable. And in the first model, I used the cow, whether it's ketotic or not, it's a dichotomous variable. And the third model is I use the number of the mean milk BHB. And we can see that the p-value is very small, so the mean BHB, this model is better than the dichotomous ketotic status. And the fourth model is to use the farm size, and the fifth model is to use the farm number. So we can see that whether to use farm size, which is small, medium, and large, or just use the farm number directly is not really significant difference. And to compare Model 3 and Model 4, the p-value is 0.016, so farm size is more better to fit the model than the mean milk BHB. And in the Model 6, I stratified the lactation and to see whether if I do the stratification, it will be better, and it is that stratify with lactation is better than no stratification. And Model 7 is to stratify with farm size, and also stratify with farm size is much better than without stratification, and stratify with farm size is much better than stratify with lactation. And the Model 8 is that I include the mean milk BHB and the factor lactation and stratify with farm size to see whether Model 8 is better, but we can see here that the log likelihood is very similar for Model 7 and Model 8. So Model 8 is no better than Model 7. And the final model, Model 9 is I stratify with farm size and stratify with lactation and to see whether it's better. And now I can see that stratify with both farm size and lactation compared to stratify only with farm size has a higher log likelihood, and the p-value is also very significant. So stratify with farm size and stratify with lactation, both is better. So the final model, I decided to use mean milk BHB, stratify with farm size and stratify with lactation. And we can see here as the mean milk BHB increase, the probability of getting pregnant is lower, and multiply by 0.6, but the result is not significant. So the time from calving to pregnancy is not significantly affected by mean milk BHB. And the survival curve shows different trends within and after 30 days postpartum. So maybe next time I can divide the early lactation period and later lactation period. And also the cost model, if I stratify with lactation and farm number, it all shows a higher log likelihood. So some farm level factors would be influential in this study. And also in this analysis, we didn't include a very important confounder, which is milk yield. So further analysis is still needed. Thank you for your attention. Feel free to ask questions.